Properties of inverse trigonometric functions. If y is equal to sin inverse of x, then x is equal to sin y. And if x is equal to sin y, then y is equal to sin inverse of x. This is equivalent to sin of sin inverse x is equal to x for every x belongs to closed interval -1 to 1. And sin inverse of sin x is also equal to x when x belongs to closed interval -pi/2 to pi/2. Same is true for other 5 inverse trigonometric functions as well. Some other properties of inverse trigonometric functions. First one, in that sin inverse of 1 by x is equal to cosec inverse of x. X is less than or equal to -1 or x is greater than or equal to 1. Second one, cos inverse of 1 by x is equal to sec inverse of x. Again here x is less than or equal to -1 or x is greater than or equal to 1. Third one, tan inverse of 1 by x is equal to cot inverse of x when x is positive. Let us have proof of first one. Let y is equal to cosec inverse x. This implies x is equal to cosec y. This implies 1 by x is equal to 1 by cosec y when you take reciprocal. This implies 1 by x is equal to sin y. This implies sin inverse of 1 by x is equal to y. So we have taken y is equal to cosec inverse x, and we have proved y is equal to sin inverse of 1 by x. Therefore, sin inverse of 1 by x is equal to cosec inverse of x. Second set of properties. That first one, sin inverse of minus x is equal to minus sin inverse of x. X belongs to closed interval minus 1 to 1. Second one, tan inverse of minus x is equal to minus tan inverse of x when x belongs to set of real numbers. Third one, cosec inverse of minus x is equal to minus cosec inverse of x when x is less than or equal to minus 1, or when x is greater than or equal to 1. This also we can write as modulus of x is greater than or equal to 1. Let us have proof of 1. Similarly, we can prove other two. Let y is equal to sin inverse of minus x. This implies sin y is equal to minus x. This implies x is equal to minus sin y. This implies x is equal to sin of minus y. As we know, sin minus theta is equal to minus sin theta. This implies sin inverse of x is equal to minus y. This implies y is equal to minus sign, you can take the left side, minus sin inverse of x. We have taken y is equal to sin inverse of minus x. We have proved y is equal to minus sin inverse x. Therefore, sin inverse of minus x is equal to minus sin inverse of x. Third set, in that first one is cos inverse of minus x is equal to pi minus cos inverse of x. X belongs to closed interval minus 1 to 1. Cot inverse of minus x is equal to pi minus cot inverse of x when x belongs to R. Third one, sec inverse of minus x is equal to pi minus sec inverse of x when modulus of x is greater than or equal to 1. Proof. Let y is equal to cos inverse of minus x. This implies cos y is equal to minus x. This implies x is equal to minus cos y. This implies x is equal to cos of pi minus y. As we know, cos pi minus y in second quadrant, that is minus cos y. This implies cos inverse of x is equal to pi minus y. This implies y is equal to pi minus cos inverse of x. We have taken y is equal to cos inverse of minus x, but we have proved y is equal to pi minus cos inverse of x. Therefore, cos inverse of minus x is equal to pi minus cos inverse of x. Fourth set, and that first one is sin inverse of x plus cos inverse of x is equal to pi by 2. X belongs to closed interval minus 1 to 1. Second one, tan inverse of x plus cot inverse of x is equal to pi by 2. X belongs to R. Third one, sec inverse of x plus cosec inverse of x is equal to pi by 2. And modulus of x is greater than or equal to 1. Proof. Let y is equal to sin inverse of x. This implies x is equal to sin y implies x is equal to cos pi by 2 minus y, that is the first quadrant, is equal to sin y. This implies cos inverse of x is equal to pi by 2 minus y. This implies y plus cos inverse of x is equal to pi by 2. This implies what is y? Sin inverse of x plus cos inverse of x is equal to pi by 2. Next set, tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y divided by 1 minus xy when xy is less than 1. Second one, tan inverse of x minus tan inverse of y is equal to tan inverse of x minus y divided by 1 plus xy when xy is greater than minus 1. Proof. First one, let theta is equal to tan inverse of x and phi is equal to tan inverse of y. This implies x is equal to tan theta and y is equal to tan phi. Now tan theta plus phi is equal to this formula we have learned last year, that is tan theta plus tan phi divided by 1 minus tan theta into tan phi. This is equal to, what is tan theta? X, tan phi y divided by 1 minus xy. This implies theta plus phi is equal to tan inverse of x plus y divided by 1 minus xy. Implies, what is theta? Tan inverse of x. What is phi? Tan inverse of y is equal to tan inverse of x plus y divided by 1 minus xy. Next one, 2 tan inverse of x is equal to sin inverse of 2x divided by 1 plus x square when modulus of x is less than or equal to 1, that is minus 1 is less than or equal to x is less than or equal to 1. Second one, 2 tan inverse of x is equal to cos inverse of 1 minus x squared by 1 plus x squared when x is greater than or equal to 0. Third one, 2 tan inverse of x is equal to tan inverse of 2x divided by 1 minus x square when modulus of x is less than or equal to 1. Proof. Let y is equal to tan inverse of x. This implies x is equal to tan y. Now sin inverse of 2x divided by 1 plus x square is equal to sin inverse of 2 tan y divided by 1 plus tan square y is equal to sin inverse of sin 2y as we have learnt last year. This is equal to only 2y. This is equal to 2. What is y? Tan inverse of x.